This is Mrs. Zappia with Lesson 3, Solving for Unknown Angles Using Equations. This is on page 16. Student outcomes for this lesson. Students solve for unknown angles in word problems and in diagrams involving all learned angle facts. Pause the video and copy the essential question. What are the first two steps for solving for an unknown angle? In the opening exercise, two lines meet at a common vertex of two rays. The measurement of angle COF is 134 degrees. Set up and solve an equation to find the value of x and y. Pause the video and complete the opening exercise. So let's start out with looking at the figure. We have angle FOA, and that extends from here to here, and that is comprised of three angles. And we know that the sum of the three angles is 134 degrees. X is the middle angle. That is the angle that we are solving for. So we write an equation, 14 plus x plus 90 is equal to 134 degrees. Combine your like terms by combining your constants, 14 and 90. That equals 104. Then subtract 104 from both sides of the equation to solve for x, and that gives us a value of 30. So now we know that the measure of angle x is 30 degrees. Next, we need to solve for y. So look on the diagram to see where angle y is. Now, angle relationships that will help us to solve this is angles on a line. So if we take a look at this line that has angle y on it, and we see angles on a line, the first angle is angle y, and the second angle is the 134 degree angle that is comprised of those three angles. And so we can write an equation, y plus 134 equals 180. Solve your equation by subtracting 134 from both sides of the equation. That leaves you with y equals 46 degrees. So we have solved for both x and y. We'll come back to example 1 after we complete exercise 1. In exercise 1, 5 rays meet at a common vertex. In a complete sentence, describe the relevant angle relationship in the diagram. Set up and solve an equation to find the value of A. Taking a look at our diagram, here is the angle A that we are solving for. I also notice that I have a 143 degree angle, and I have a 90 degree angle that is made up of two adjacent angles, and I have another 90 degree angle here. So I need to be careful when I set this up. These are called angles on a point, and angles on a point have a sum of 360 degrees. So I'm going to start adding my angles. I have 143 plus, and I notice that this is a 90 degree angle, so I'm going to go ahead and add that in, 90 plus, and then this section right here. This is a 90 degree angle comprised of two adjacent angles. So the part that's right here is actually 90 minus 21. So I'll put that 90 minus 21. And angle A. And all of that has a sum of 360 degrees. Next, combine all of our constants. So we have 143 plus 90 minus 21 plus A equals 360. This has a sum of 302. 302 plus A equals 360 degrees. Subtract 302 from both sides of the equation to solve for A. This is a zero pair, leaving you with your variable A and your answer of 58 degrees. And so the measure of angle A equals 58 degrees. You want to be especially careful when you have overlapping angles like that. Next, Pause the video and complete example A. Set up and solve an equation to find the value of x. All right, so you know that these are angles on a point, and we know that they will have a sum of 360 degrees. So we have 90 plus 123 plus x is equal to 360. Combine your like terms by combining your constants. And that gives you 213 degrees. 213 plus x equals 360. Subtract 213 from both sides of the equation to solve for x. That equals 0, leaving you with your variable, and your answer is 147 degrees. Then look at your answer and make sure it makes sense. It's an obtuse angle, so it will be more than 100, or rather more than 90 degrees, but less than 180 degrees. So it makes sense. Example 2. 4 rays meet at a common vertex. In a complete sentence, describe the relevant angle relationship. In the diagram, set up and solve an equation to find the value of x. Find the measurement of angle BAC and DAE. So taking a look at our diagram, first let's identify the angles that we're working with. Angle BAC. BAC is this small angle right here, which is the measure of angle x. And DAE is the measure of this angle, which is called 5x. So the relevant relationship, I see that I have a 90-degree angle. I know that if I go all the way around in a circle, I will have 360 degrees. So my relevant relationship is angles at a point, and I know that that will have a sum of 360 degrees. So I'm going to carefully add all of the angles together and know that they add up to 360. I'm going to start with this 90-degree angle. I have 90 plus 204 plus x plus 5x. And together that will have a sum of 360 degrees. Next, I'm going to combine my like terms. This gives me 294. X plus 5x is 6x equals 360. To solve my two-step equation, I'm going to first subtract 294 from both sides of the equation and simplify. That's going to leave me with 6x on the left and 66 on the right. This says to multiply by 6. The opposite of multiplying by 6 is dividing. You can divide by 6 or multiply by the reciprocal. I'm going to multiply by the reciprocal of 6, which is 1/6. Remember to do the same operation with the same number on both sides of the equation. So we have 1/6 times 6 is 1. 1 times x is x. And 1/6 of 66 is 11. So I have solved for the variable x. Now to solve for the angles. This angle right here is x, so that will be 11 degrees. And this angle is 5x, so that would be 5 times 11. And that's going to give me 55 degrees. So the answer to our question, we have the measure of angle BAC, which was the small angle, is 11 degrees. And we also have the measure of angle DAE is 55 degrees. Exercise 2. 4 rays meet at a common vertex. In a complete sentence, describe the relevant angle relationship in the diagram. Set up and solve an equation to find the value of x. Find the measurement of angle CAD. Pause the video and complete exercise 2. Resume the video to check your answer. The relevant angle relationship. We have all of these angles are at a point and sum to 360 degrees. We can use that information to write the equation. We have 3x plus 60 plus 12x plus 90 equals 360. And we can add those in any order, any grouping. Combine our like terms. The 3x plus the 12x is the 15x, and 90 plus 60 is 150. From there, your next step is to subtract 150 from both sides of the equation to get rid of this. So we subtract it from the left and we subtract it from the right. And we simplify. And that gives us 15x equals 210. To eliminate this coefficient, 15 times x, you would divide by 15. Now remember that you can either divide both sides by 15 by using a fraction bar, or you can multiply it by the reciprocal. Multiplying by the reciprocal would be 1 over 15. 1/15 times 15 is 1. 1 times x is x. And 1/5 times 210 is 14. So we have solved for the variable and we got 14. But notice that we have an angle here which is 12 times 14, and this angle is 3 times 14. So it said find the measurement of angle CAD, which is this angle. So that's going to be 3 times x, and 3 times 14 is 42 degrees. So our answer is 42 degrees. Exercise 3. Two lines meet at a common vertex of two rays. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve an equation to find the value of x. Find the measurement of angle BAC and angle BAH. Let's identify the angles that we're looking to solve for. BAC is right there, and then BAH is adjacent to it. I notice that I have angles at a point. That's going to be 360 degrees. I also have a pair of complementary angles that will have a sum of 90 degrees. And I also have angles on a line which will equal 180 degrees. So there are a lot of angle relationships here. What we want to know is what's the best one to help us to solve for the missing angles. Well, I notice that these two angles that we are solving for, they are adjacent. And so I can add them together. I also notice that I have intersecting lines right here. And remember that intersecting lines form vertical angles, and vertical angles are equal in measure. So that's my relevant relationship that's going to help me solve this problem. Vertically opposite and equal in measure are two different angles, so let's label those. I have this angle, which is called EAD, and do you see the other one? CAH. Okay, so I have this angle, and they are equal in measure. So since they're equal in measure, I can write an equation, and that equation will be 30 degrees plus 90 degrees. And that's going to be equal to the sum of these adjacent angles, 5x plus 3x. Can you solve it from here? 30 plus 90 is 120. 5x plus 3x is 8x. You can either divide by 8 or multiply by the reciprocal of 8. I'm going to multiply by the reciprocal of 8. That's going to be 1/8. 1/8 of 8 is 1. 1 times x is x. 1/8 of 120 is 15. So I have solved for x. Now I need to find the measure of those two angles. The measure of the first angle will be 5 times 15, and the measure of the other angle will be 3 times 15. 5 times 15 is 75. 3 times 15 is 45. Answering our question, we have the measure of angle BAC, and that one is 75 degrees. And then the other one, we have the measure of angle BAH, and that was right here, and that one is 45 degrees. it's your turn. Two lines meet at a common vertex of two rays. In a complete sentence, describe the relevant angle relationship in the diagram. Set up and solve an equation to find the value of x. Find the measurement of angle DHF and AHD. H is the vertex, so DHF will be right here. That's the first angle you're going to find. And AHD, right here, is the second angle that you're going to find. Notice that these are adjacent angles. Pause the video and complete exercise 3. All right, let's take a look. We have vertical angles formed by these two lines, and the sum of these two angles is going to equal the sum of these two angles. So I'll write the sum of these two angles, and that's going to be 5x plus x, is equal to the sum of these two angles, which is 42 plus 90. Simplify. 5x plus x is 6x. 42 plus 90 is 132. From here, I can either divide by 6 on both sides of the equation or multiply by the reciprocal, which is 1/6. 1/6 times 6 is 1. 1 times x is x. 1/6 of 32 is 22. Now, we're not quite done with the problem. You are solving for DHF. DHF was right here, and that one is 22 degrees. The measure of angle DHF is 22 degrees. And then the other angle would be 5 times 22 degrees. The measure of angle AHD is equal to 5 times 22, which is equal to 110 degrees. Example 4. Two lines meet at a point. Set up and solve an equation to find the value of x. Find the measure of one of the vertical angles. So, taking a look at the relevant angle relationship, I know that when I have two intersecting lines, I have vertical angles, and vertically opposite angles are equal in measure. So I can write an equation. I know that 3x is equal to x plus 30. Notice that I have variables on both sides of the equation. To solve the problem, I need to get all of the variables on the left side and the constant on the right. And that means I need to get rid of this x. Well, the opposite of plus x is minus x. So if I subtract x from both sides of the equation, 3x minus 1x is 2x, and x minus x is 0, and 0 plus 30 is 30. Now, 2 times x. I can either divide by 2 by using a fraction bar, or I can multiply by 1/2. I'm going to divide by 2 this time. Divide by 2 on both sides of the equation. 2 divided by 2 is 1. 1 times x is x. 30 divided by 2 is 15. So I have solved for x. Now, find the measure of one of the vertical angles. So just look and think which one would be easier to solve. Would it be 3 times 15 or 15 plus 30? I think I'll do this one, 15 plus 30. And so that's going to equal 45 degrees. Exercise 4, your turn. Set up and solve an equation to find the value of x. Find the measurement of one of the vertical angles. I know that vertical angles are opposite in measure, so I know that x plus 54 is equal in measure to 4x. I want my terms with variables on one side of the equation. I notice that this is the smaller amount, so I'm going to subtract x from the left side and do the same thing on the right side. That's going to leave me with 54 on the left, and 4x minus x is 3x on the right. Next, I can either divide both sides by 3 using a fraction bar, or I can multiply by the reciprocal. I'm going to multiply by the reciprocal of the coefficient, 1/3. Do the same thing with the same number. 1/3 of 3 is 1. 1 times x is x. 1/3 of 54 is 18. And so I have solved for the variable and I got 18. My last step then is to substitute x for one of those angles and find the answer. 4 times 18 is 72. So the angle is 72 degrees. And these are vertically opposite angles, so they will both be 72 degrees. In this lesson, you have learned the steps for solving an unknown angle. Identify the angle relationships. Set up an equation that will yield the unknown value. Solve the equation for the unknown value. Substitute the answer to determine the angles. Check and verify your answer by measuring the angle with a protractor.